Hello Matrix and welcome again. Today we're going to be doing the fourth proof that you need to know for your final matric exam, which is the Tan-Chord Theorem. And the Tan-Chord Theorem is that CAE, this angle here, is equal to ABC. So this is what's sometimes called the sailboat theorem because this looks like a sailboat. All right, so what do we need to do to prove this theorem? So as always, I start with a construction. So what I'm going to do is I'm going to construct a line through O from A, and then I'm going to call this point F, and then I'm going to join these two lines as well. Okay, so that's the construction. So now I just need to write that down. So my construction . And so I'm going to construct AF through O. And then they'll see this on your diagram. And I'm also going to just say join FC. I've seen some proofs they don't actually join the FC, but I'm going to do it here because it makes it easier for us to see what's going on. Okay, so now let's start with our proof. So what do we need to prove? What is the RTP required to prove? Well, we need to prove that because this is the sailboat, here, see the sailboat, I need to prove this, and I like to draw a Z like you do with alternate angles, but it's not the Z, it's the line, it's the angle opposite the Z. So I do that, and then it's the opposite one. So I need to prove CAE is equal to CBA. Okay, so that's what I need to prove. Okay, so what do I need to prove that? Well, to start off with, I know that this is a right angled triangle. This is a right angle because of the this is drawn through the radius. So this is the, drawn through the center. So if this is drawn through the center and it connects to the tangent, it's perpendicular to the tangent. So I can say, therefore, that FAC, this one, plus this one, CAE, is equal to 90 degrees, okay? And that is because of the tangent is perpendicular to the line through the center. Okay, so that's, if you remember this, we get the, if we have the center of the circle and then the radius and then the tangent, then we know that this is 90 degrees. I've sometimes heard it say perp tan rad, perpendicular, but it's actually the reason you give is tan perpendicular to the line through the center. Or you can also say tan perpendicular to the radius. Now we know that these are 90. Now the second thing we know is that FCA is also 90. So we knew that this was 90 and we know that FCA is equal to 90. FCA, and that's because of the angles in a semicircle, because this, if it's going through the center, is a semicircle, equals 90 degrees, angles in semicircle. Okay. Now, because this is 90 degrees, we know that then AFC, this one, and this one is going to be 90. Therefore, AFC plus FAC equals 90 degrees. Okay, so I want to highlight now what we've got. See, we've got FAC and FAC. So these two are connected. And we need to prove that CAE equals CBA. So we are close. Because if I can prove that FAC is equal to ABC, or CBA, I can therefore connect them. So then CAE is equal to CBA. Well, these are, we know that these are equal because they are both in the same segment. So I can say, but FAC or CFA, I'm calling it FAC, but FAC equals CBA, this one. Angles in the same segment. Just going to write through this. So now we've proved that there, we can see now they're connected. CAE is equal to CBA because of the connection with the FAC. So we've done it. Therefore, therefore, CAE equals CBA. Okay, so this is probably the trickiest one of the 4 that we've done so far. So watch the video again if you didn't understand all of it. Watch the 3rd and 4th time, as many as you need to kind of figure out what's going on, and then try and do it yourself and then practice. So as long as you understand the proof, then it's easier to learn. So if this video helped you, please find the subscribe button down below, and so you can subscribe to more videos and get notifications when the next ones come out. Like, share, and all that good stuff. And I will see you next time when we'll be doing prop theorem.